we've touched on a lot of topics, but we haven't fully addressed fisheries yet in our class. So I wanted to start that today formally. Tuna, big tuna right there, major target of humans for a long time. Great source of protein, all kinds of good nutrition value in here. Very profitable in terms of the economics, especially for the larger, more valued species. Today, and I apologize, I'm probably going to ramble. I am still jet lagged, and I haven't had a chance to look over this lecture recently, so I might stumble a little bit here. But I want to talk about historic perspectives on our systems, eventually go into the current state of our fisheries, talk about overfishing, which is one of the big worries and management concerns, and eventually we'll talk about some other things too, if we get to that today. So I like to start off talking about fisheries from a historical perspective, because I think it's important it's very easy to take the last 20 years or some short time frame and believe that is our frame of reference. History is important because obviously it helps us frame what's going on now, the challenges we face now. It can tell us specifically how we got to the point in time and the point in this management situation where we are now. History can tell us what has worked in the past, what has or hasn't been effective, and rather than having to invent the wheel over and over again, we can maybe learn from our ancestors what was an effective approach to manage a resource like a fishery. And then knowing what the, say, abundance of a given species was back in the day can be used as one potential source of guidance for restoring the fish stock to some target level. Increasingly, with climate change and the massive change that we're exhibiting on the face of our planet, we maybe need to question whether historic baselines are achievable or realistic in a modern context, but nevertheless, they're still important to start the discussion. And lastly, it's important to talk about history because we've been interacting with these systems for many thousands and thousands of years. And this is not, even though some of the most intensive fishing pressure has been brought about in the last few decades, we really have this long history with these important parts of our planet. So we manage our local fisheries, such as these in California. Here are abalone stocks, poorly. So these are landings, and we've talked about this before, but just to reiterate this is the landings data. This is not the actual number out in nature. This is the number that folks removed from a natural source, put on their boat, brought their boat to the dock, and then when they landed their catch, this is the volume that we're looking at here. Again, as with many fishery things, we're not looking at actual numbers of individuals, we're looking at the biomass. This is metric tons. And this is abalone data. Now what we see is a couple of things here. We've mentioned this before, but so we start with either the best tasting or the easiest to get at species. We hammer that species, and then as it starts to become depressed, we switch to the next best thing, or the next least hard to get thing, and go on down the road. And so what we have now is we have a fraction of the critters that we used to have. And this is not a California problem. This is going on around the world. And so we see this with tunas, we see this with salmon, we see this with cod, All these things follow this very similar pattern of historically lots of them, now not so much, in these very consistent patterns. So let's start off framing with a typical story.
We have been fishing for 40,000 years, constantly improving our fisheries and our nets. Fishing became an industry. It's no longer a question of family, but of investment and technology. To increase our catch, our fishermen formed fleets. What changed everything is the invention of the deep sea trawl, a large net with a funnel-shaped opening, like the mouth of the whale shark. Our nets are so large that some measure 40 kilometers. Then entire factories took to the sea. We use probes, radar, and focus all our ingenuity on hunting down marine life.
That's all fish in that net.
Every year, we fish 90 million tons of wild fish globally. Half this amount is fished by only 1% of our fishing boats. My trawlers, my seines, my nets are so vast that I no longer select my catch. I take all that comes and sort it later depending on the market value of the fish. Peruvian anchovy, Alaska pollock, Atlantic herring. We just scoop it all up. There's no limit to our predation, apart from the fish quotas fixed by scientists. But who can prevent us from exceeding them? Worldwide, 80% of commercial fish stocks have been declared fully exploited or overexploited.
It's actually higher than that now.
Our fishing has reached a ceiling. We are at a biological limit. How could we have got to this point? Our intensive fishing sacrifices millions of fish. These are the waste, the rejects of the catch, or just the fish crushed to death in our nets. Fish killed for nothing.
Okay, so that's the setup of the problem.
Traps that still remain active are on the coasts of Cadiz.
This is in Spain.
Tuna migration, catching the tuna as they cross the Strait of Gibraltar each spring. For over 3,000 years, local fishermen have used a maze of nets to trap the tuna.
Porque en el año 47 recogieron en Guadalajara 45, 46,000 atunes.
Lentamente se ha ido jalando la red, empujando hacia la superficie a los atunes. La maestría y el buen éxito de la operación se encomienda a un solo hombre, el capitán de la almadraba, jefe indiscutible de los pescadores, cuyas órdenes son ley.
This is a traditional fishery.
Between the fishermen and the tuna is the culmination of an ancient tradition. Oceanographers and ecologists recognize it as a sustainable way of fishing. But despite the fishermen's continuing efforts, the emergence of industrial fleets equipped with the latest technology seriously threatens their survival.
Mi bisabuelo fue almadrabero, mi abuelo fue almadrabero, mi padre fue almadrabero y yo he sido almadrabero. Mi hijo no será almadrabero porque las almadrabas se perderán. Si las almadrabas se quedan desde hace 3.000 años y el atún nunca va a faltar, y de pronto, de 50 años para acá, que me aparecen unos barcos en el Mediterráneo, empieza a faltar atún, ¿por qué falta el atún? ¿Porque las almadrabas lo ha destruido? No, lo están destruyendo los cañeros después, ¿no? ¿O no?
Okay, so this fishery off Spain in the Mediterranean is done by slightly modified, but with traditional methods, and it's been going on, as we just saw, for a long time. This is some data from Enrique Sala, who actually went and looked through, and so this is a neat story. These are two different villages in Spain. In Cadiz, this is pretty cool because we actually have documented data in terms of the tax records and such of the landings of these particular fish. Now, because this was back in the day before modern science, we're recording this as the number of tuna, not the metric tons landed. But what we see is, surprise, surprise, this same pattern, right? So we start up high, whether we're talking about the square or the circle, we start up relatively high, and then over a relatively short period of time, the numbers crash and are but a fraction of what they were. Again, the same story over and over again. So the important point here is that overfishing is a common phenomenon of fisheries worldwide. And we have a lot of historical evidence that populations used to be higher than they were subsequently after exploitation began, or just compared to right now. So let's look at an example here. One of the examples I like is from this paper that came out about a decade ago that I think does a nice version of this. And these guys try to get a reasonable sample of just a single ecosystem. In this case, they were looking at coral reef ecosystems. And they wanted to see if they could document change. So they had folks from several different disciplines: archaeologists, biologists, geologists, different folks, a lot of ologists. Look at 14 different areas of coral reefs. And they looked at 7 different time periods from before humans were presumably in the system to right now. Look at 7 different guilds of critters. And their overriding question was, hey, how has this ecosystem changed over time? So here are those 14 different reef areas that they sampled. A lot in the Caribbean / Western Atlantic, up in Bermuda, in the Red Sea, and then in the sort of Indonesia, Australian region. These are the time periods that they worked on. So we had before human influence, which they defined as 40,000 years before present to 1503. I mean, it depends on which reef as to the exact time range. Then we had the hunter-gatherer era of humans, which again is going to vary somewhere between 20,000 years before present and 1824. And then we have the era when we're primarily doing agriculture, where humans are getting a lot of their calories from agriculture. We have the period of colonial occupation, which is different from colonial development. And then the modern era before World War II and the current modern era post World War II. They looked at these 7 different guilds. So the guilds included so-called megafauna, large-bodied things. So large-bodied carnivores, large-bodied herbivores, and then they also had small carnivores, small herbivores, so those 4 different guilds. And then we had architects, what we sometimes now might call ecosystem engineers of these systems. So corals, seagrasses, and then suspension feeders like oysters and the like. And so they defined a couple different eras. Here are those eras in more detail. And so they had the pristine areas before humans presumably came into contact with these systems. And so, for example, here, how do we know it was there? We have some geological record, right? So we know that this coral species and that coral species and that coral species were here, for example. We can get that by, for example, coring into the reef, taking a core and then looking at the old coral that's buried underneath the modern coral, for example, and using radiocarbon isotopic dating to get the age of these rigid structures. Then we have an era of where the resource is relatively abundant or common, or the gild it would be abundant or common. And so humans were in the picture here, but no evidence of major change or major depletion. And so an example of how you might figure that out is by looking at the size of the fish backbones in midden piles, right, in refuse piles of coastal villages. And so if we see these things not really changing over hundreds of years, let's say, it's a pretty good indication that the population was still relatively robust. They had relatively large individual fish, let's say, in that nearby that community. Then the next phase would be something like a depleted, or the abundance is relatively uncommon. So they're present, but just not like they used to be. And so this is showing that humans are not only interacting with this system, but interacting with this system most likely decreasing the abundance or size of critters. So an example of that we can how we can infer this particular stage might be to document a shift to a different species or smaller size species, again from those same midden piles. Then we can talk about an era of rarity where our presumed impact in these systems is relatively great, and we've reduced the abundance of these critters to a large extent. A term you've not seen yet, maybe in some of our reading, but we haven't discussed yet here, for example, would be catch per unit effort. Catch per unit effort is a key metric that is used in fisheries management. The idea there being, let's say we got 1,000 fish in 1950, and we got 2,000 fish in 2010. So you might look at that and go, oh, the population has gone up. But if we had 2 boats fishing in 1950 and 1,000 boats fishing in 2010, clearly that's we need a control for our fishing effort, and that puts a different spin on those numbers. And so standardizing by how many vessels, how many hours fishing, there's different ways to do it, but standardized by the effort that we put into fishing is the so-called catch per unit effort, whatever that effort is defined as. And so rarity, we'll see that the catch per unit effort for the same effort goes down. And then we get something that we might call ecologically extinct, meaning the critters might still be, they're still present on the planet. They might even still be present in the area, but they're so rare as to not be serving their ecological role that they traditionally serve. So if we think of something like an oyster, let's say, that filters, if we have a healthy large oyster population, it might filter the volume of this bay, let's say, once a day. That's going to have a strong influence on the dynamics of this ecosystem because it's going to pull all these things out of the water column. Not just plankton, but also maybe sediment. So if we had a bay full of oysters, it's going to act to essentially clean the water very frequently, a large volume, etc. Versus if we have 20 oysters in the bay, yes, they're not technically extinct, but in effect, they're not having the influence and they're not having that ecological function they previously were having. And so that's the idea of ecologically extinct. Yesterday, I was taking my son snorkeling off of Waikiki Beach, and it's super shallow there, super rocky, and we're going in the water, and we're obviously leaving to come home, so I didn't want to use all my dive booties and everything, get everything wet, so we're just walking out in our bare feet, and it was very rocky, it's very shallow at Waikiki, and rocks everywhere. And so we're kind of going out, and we're not trying to walk on the rocks, trying to float, and so we're going, and all of a sudden this big rock was right in front of me. I'm like, oh my God, this rock is about 1 inch from the surface. I'm like, that's crazy. And I'm looking at it and I'm feeling it. It's like, this feels like a strange rock. And I'm looking, it's very dome shaped. I'm like, wait a second. So it was a green sea turtle. And so I'm like, Gabriel, come here, look at this. And so we definitely have turtles, right, still around, but they are not the abundances they used to be in many of our coastal systems. So again, might be present, but they might be ecologically extinct. And then, of course, we can talk about something like the Caribbean monk seal, which we know for sure has been driven extinct. So we have these different categories of exploitation. And this is what they found. This is change over time. And these are just prehistoric, right? These are these different eras we just talked about. This is the relative abundance, and here are these categories. We have large herbivores, large carnivores, small herbivores, small carnivores, corals, suspension feeders, so things like our oysters, and seagrass. And here we go from pristine all the way up to extinct. And again, we see the same pattern. Recall, this is a completely different data set from our traditional fisheries stuff. This is looking at a whole variety of sources from archaeological samples, whatever. And so this is a bit generalized, right? Because we're sort of making a lot of binning here and assumptions, but nevertheless, we see this same pattern. Back in the day, they had this relatively high abundance, and the things have all become at least rare, right? Well, large herbivores, this is showing that they're that a fraction of them. Well, yeah. Anyway, yeah, you guys get it. I'm too tired to explain this properly, but we're going from relatively from a pristine levels to now much reduced levels, and we see this with all functional groups. We see this perhaps most clearly with the largest critters, the largest bodied things, the large-bodied herbivores, large-bodied carnivores, but the pattern shows up in every aspect of the ecosystem. So here's a quote. Large animals decline before small animals and architectural species, what we might call ecosystem engineers now. And Atlantic reefs declined before reefs in the Red Sea and Australia, but the trajectories of decline were markedly similar worldwide. So again, overfishing is common around the world. We have a lot of evidence that this has been going on for a long time. And this is the first hint that we've seen that ecosystem collapse might start with overfishing. So next, here's this paper from Jeremy Jackson and a bunch of folks that came, a very, very influential paper, got a lot of attention. And these guys argue that overfishing precedes all other pervasive human disturbances to everything else. Pollution, invasive species, blah, blah, blah. That overfishing is almost always the start of the degradation of coastal ecosystems. These guys, similar to that last study I just mentioned, these guys did a similar thing. They looked at the historical records, the paleoecological records. They looked at marine sediments from as far back as 125,000 years ago. They looked at archaeological records from coastal villages and such. They looked at more modern, just like I mentioned Enrique Sala's data, historical records. And then they looked at more detailed biological surveys, ecological surveys from about the last century. And in this case, these guys looked at a couple different types of coastal systems. Coral reefs, kelp forests, seagrass beds, estuaries, and continental shelf areas. And this is what they found. So coral reefs, we first see human disturbance, which leads to a shift in the dominant species on these reefs, which in turn leads to the decline of the reefs themselves. For example, this can take a couple different pathways, but for example, one of the things we see frequently is a decrease in large herbivorous fishes and or sea urchins. Once we knock those dudes down, the algae that they used to eat is now released from that grazing pressure, and so the algae goes up. We also see an increase, we sometimes see an increase in sedimentation and nutrients after that. And then in aggregate, we see a decline in coral abundance. So this is the story definitely in West Atlantic coral reefs.
What's this paper?
This is Jackson et al., 2001. I know. Everybody's tired. I'm tired too. Okay, we've seen an example of knocking down starfish predators, which leads to an explosion of the starfish and things like crown of thorns starfish, which in this case eat coral, and then the coral become rarer. So here is a cartoon for you guys of the trophic food web back in the day versus now. So back in the day, so let's look at this guy right here. So this is saying that sharks sometimes eat birds, right, if they're on the surface. Sharks also eat monk seals. Sharks also eat invertebrates. So things they mostly do, we have a thick line. And things like the birds, which they might occasionally catch a bird that's sitting on the surface, they might come up and grab it. But it's not as thick a line as for example, monk seals or sea turtles, etc. This is the old school one. This is the old back in the day thing. Also, the relative abundance of these critters in the overall ecosystem is represented by the size of their name. So for example, corals are abundant, they're bold. Macroalgae in this coral reef system, it's absolutely present, but it's comparatively rare relative to, say, coral. This is what we've done to coral reefs worldwide. Now we've added in this new thing, people. And people are the primary thing that are driving this system now. People are the primary harvester of grazing invertebrates, of coral, of manatees, or at least killing of manatees, sponges, crocodiles, you name it. So we are at the center of this web now. What happened with kelp forests? Well, we first began by removing the apex predators. Apex predators go away. We see an explosion of the herbivores. In the case of coral reefs, a lot of this pertains to urchins, sea urchins. And then those sea urchins go crazy, and then they eat the kelp or rub against the kelp, denude the kelp forest, reduce kelps, and then we have a simplified ecosystem. We lose that kelp, and then we see reduction in whole trophic levels and overall diversity on these reefs. That's what happened to our kelp ecosystems right here off of California. These ecosystems evolved, well, or at least were in place as of about 20 million years ago. We had a lot of sea otters. We had moderate levels of sea urchins. And the grazing upon the urchins by the sea otters and other things like this sheephead right here act to keep those guys in check, and relatively abundant kelp. About 2,500 years ago, the folks the humans that came to our part of the world started exploiting sea otters and drove their numbers down. And then I didn't realize this, but one of the I just was reading this on a history exhibit thing last week. But Captain Cook is one of the people responsible indirectly for this fur trading, where Captain Cook goes to Hawaii, meets the folks from Hawaii. They sail up back to Alaska. They break a mast, have to come back, and that starts. And they first visited, for example, the Big Island in a sort of time of peace. They come back in the time of war, the season of war, and the Hawaiians don't like them, and the tensions are getting high. So somebody steals one of Cook's rowboats, basically, and then he gets angry and he goes onto the mainland and he takes their leader hostage, Kamehameha, and says, "I want my boat back." And then tensions flare, and then Cook gets killed. So Cook gets killed. His lieutenant essentially calms things down, gets everything under control. They sail to China. In their hold, they have sea otter pelts from the Pacific Northwest, and they find that they get sold for incredibly high prices in Hong Kong and these Chinese ports. And so that, in turn, spurs the Russians to start coming into Alaska and down the California coast, Washington, Oregon, California coasts, to hunt the sea otter. So maybe if he hadn't died, maybe things would have been different, or at least delayed a little bit. But in any event, these fur traders come in. They massively nuke, or cause to be nuked. If they don't do it themselves, they buy pelts from Native Americans, and they reduce the sea otter populations. And then we see an explosion in the sea urchin population. Man, what are they saying? I don't know if I'm speaking correctly. So we nuke the sea otters. The sea urchins, released from that predatory control, explode, and then we see a reduction in the extent of our kelp forests. A small pocket survives near Monterey, and then some others up towards Alaska, of sea otters. We start managing them differently, in part because of the Marine Mammal Protection Act we heard about last time. And that says you can't take an otter no matter what. And so as these guys recover, this also had to do with water quality improvements as well, but as these guys start to recover, sea urchins decrease. Kelp forests are much more abundant than they were, say, in the early 1970s. And so this is the same story here in Southern California, with the additional complicating factor of we had really high exploitation starting in the 50s thanks to the recreational scuba industry. Really, really high in large human population centers. Really high exploitation, not just of the otters, because we didn't really have that many otters down here. We had some, but not a gazillion. But we had a lot of other things like sheephead and other predators, but that essentially did the same thing. So by removing the things that ate the kelp, we allowed those eaters, those urchins, to explode and therefore reduce the kelp. In our part of the world, our urchin fishery has helped fill that niche. So humans, in effect, are acting like a sheephead and attacking the urchins and keeping them relatively low. All right, so again, just like I showed you before, here's a historic diagram of kelp forest before, and so this would be our story here, let's say. In California, we have all these things going on. This is what it is now. Again, people are at the center of these food webs. People are at the center of these coastal ecosystems driving the dynamics. Indeed, on the East Coast, we actually completely lost this guy's sea mink in the 1890s, went extinct, and so those guys are particularly hard hit in terms of we don't have a way to replace that guy. In terms of tropical seagrass beds, again the same story. We removed the large herbivores, the seagrass density increased, and now we see a lot of skanky seagrass. The reports of some of the original sailors in the Caribbean say things like you could walk from Tortuga to Tortuga. You could walk from islet to islet on the backs of sea turtles. Now, is that true? Probably a bit of an exaggeration, but clearly what they're saying is there were at least large numbers of turtles, let's say. Manatees as well. But let's just say, turtles. These guys eat a ton of stuff. And so you can imagine these seagrass beds being mowed just like a lawn, right? We probably didn't have these super huge, long-bladed leaves that we do now. We probably had nubs because they were so heavily grazed by all these grazers. Very different system now. And so now some of the problems we have are the seagrass grows so densely. Sometimes we have problems where it does persist. So again, in this case, it was sea turtles and the manatees and dugongs. We nuke those guys out. The seagrass goes high, and this high seagrass biomass helps decrease water quality, particularly in small bay type situations. So we have a lot of rotting dead stuff potentially, which leads to more microbial populations, and that helps foster more eutrophication. And then in turn, eventually that makes it cruddy water. So these are photosynthetic organisms. If the water is so poor, the visibility is so poor that light penetration can't get very deep, that's bad for a photosynthetic organism, right? So it leads to mass die-offs of seagrass. In terms of the estuaries,
Why did people harvest the manatees and dugongs, or how did they?
to eat them.
Oh,
To eat them. I don't know if they got oil from them. I think they did, but I'm not positive about that. But primarily to eat. Okay, so then we can talk about estuaries. And so these are oyster reefs, large structures. You might think of an oyster, and you think about something your size of your hand, let's say, and you're thinking, okay. And we see these now, an oyster here, an oyster there. But oyster reefs were crazy things. Intact, robust oyster reefs in the Gulf Coast, on the East Coast, all these places where essentially they're oftentimes in estuaries, so they're muddy bottoms, silty type environments, not a lot of rocky, hard substrate. These organisms created their own reefs. Their sheer mass made just these massive structures of dead shells and essentially glued together shells by the byssal threads and the anchoring systems of these oysters. They made their own substrate. So where do oysters love most to settle? Onto other oyster shells. So oysters beget more oysters, which beget more oysters, etc. So the estimates are for Chesapeake Bay, the big giant bay on the East Coast, that we probably filtered the volume of the entire Chesapeake Bay once a day. I mean, massive, incredible numbers of these things. we've essentially lost all that. There still are oyster reefs, there still are oysters, but by and large, it's been massively reduced, the populations. As a consequence, partly as a consequence, we have lots of eutrophication happening now, right? And that's not just because we have lost the oysters, because we're doing farming practices and other things, but the oysters clearly could have helped. Oysters could take that stuff, nitrogen, eroded sediments, they filter feed it, and then they poop out these fecal pellets, right? Where this waste is bound into these little containers, and so it helps pelletize that stuff, takes the stuff out of suspension, and essentially turns it into sediment. And so a classic thing, if you guys start going to meetings, is you'll hear a lot of, especially young grad students, they'll talk about bottom up versus top down. Bottom up meaning, is the driver of this population or community dynamic coming from the quote unquote lower levels of the trophic system of the food web, or is it coming from the quote unquote higher or the top levels of that? Is it coming from the top level? Is it coming from the lion, or is it coming from the phytoplankton, from the bottom, right? In terms of the effect on the deer or something, right? So the original hypothesis we had for why these estuaries were just going to hell in a handbasket we're adding too many nutrients into the water, and that was leading to algal blooms, which was leading to and clearly that's part of it, absolutely. But more and more recently, we see that at least the beginning of this decline started with the overexploitation of the things that are eating the lower trophic levels, in this case of the suspension feeders. So it actually probably started with a quote-unquote top-down driver. Right. And this is a particularly insidious example, because once you lose oyster beds, because baby oysters recruit to adult oyster shells, as you lose the reefs, you eventually hit a point of all of a sudden there's no places for the babies to settle out. So one of the key conservation methods, restoration methods, is to save shells and dump these shells essentially onto muddy areas as substrate for the next generation. Or use reef balls. And so this gives you one little sense of how ubiquitous these oysters were in these muddy areas. I mean, they in some areas covered the entirety of the muddy bottom. And so again, same thing. Just like before, we had this simplified. We had this food web, and again, humans have gone to the center. What else has changed in terms of our estuaries? People are super abundant. Jellyfish have grown in abundance. We have many more worms because we have a much more muddy system. And then the microbial loop is much more important. So phytoplankton and microbes. So we're making the world, in terms of our estuaries at least, we're making the world more, if you love jellyfish and bacteria, you are stoked. It's a good world for you. Okay, then lastly, off our continental shelves, we can talk about excuse me. We intensively fished for things like cod and halibut for a long time. Again, I don't require this book for you, but if you guys are interested, a great book, it's just called Cod, on the history of the exploitation of it's a great book because it mixes both the history with recipes for how you can prepare cod. Cod was one of the main reasons folks came to North America, from Europe at least. This was before refrigeration, and preserved cod, salted cod, dried cod was an incredibly important protein source. And these stocks were tracked across the Atlantic all the way over into the what we now consider American and Canadian territorial waters. And this went on for centuries, and we've managed to make this fishery shut down and implode in about 50 years with our poor management. So the Atlantic cod fishery, the Georges Bank fishery, that area off of New England, is probably the classic case for overexploitation or overfishing. Technical innovation increased dramatically, and that allowed us to take any individual vessel to take way more fish than we used to be able to. And they're essentially ecologically extinct now, despite what people might be trying to tell you. Since the late 90s, they've been ecologically extinct. When I was in Hawaii, one of the places I went by was not rearing is not right, but an acclimation facility for Maine lobster. So they fly lobster. The lobsters get jet lagged. They throw them in this cold. Everybody gets jet lagged. I'm talking about jet lagged a lot today because I am. They fly the Maine lobsters out and they put them basically in nice cold water. Get them up to speed. Get them chilled before we go and cook them. Hawaii has lobster. Why are we flying in Maine lobster? Maine lobster populations are booming, bigger than they've ever been. Why? Because cod was the top predator in these ecosystems. And with the loss of cod ate lobster and other things, right? So what might look like, hey, a management success, hey, this fishery, this Maine lobster is so abundant, we can sell it all over to all kinds of people and all this and that sounds great. But it's actually a system of a signal of an unhealthy system, right? We should have lobster in that system, but they shouldn't be the dominant fishery. Okay, right. And so then here you go. Here's the story of cod. This is pretty much what you need to know about cod. Is lots and lots of fisheries from the mid 1800s going up, and then after the 1950s, let's just take a ton, right? 8 times what we historically were taking per year, for example. And not surprisingly, only lasted for a few years, leads to the crash, starts to get a little pickup, and people say, oh, yeah, everything's great, and they crash. And it stayed at this fraction of what it was since. So again, we see this ecosystem collapse even on these continental shelf areas. And we see this all over. And in this case, we're looking at different measures here. This is the length of cod we can talk about in the Gulf of Maine. We can talk about the percent of areas that have this dominant acropora coral. In Chesapeake Bay, we can talk about the oyster landings. And what you see is they all start relatively high. And even though these are very different ways to measure the functioning or the dynamics or the goings-on of these ecosystems, we are now but a fraction of what we had been historically. And so this appears to be the pattern that's emerging with humans in these coastal ecosystems. Humans come into an area, they get to an area where they previously had not occupied. We start by fishing, taking a lot of stuff. And this is not just fishing, this is just about every biological resource, I would argue. So I just was driving past some huge, giant wind turbines on the big island of Hawaii, and a lot of people are very angry with them. They think they look ugly, but they all say, oh my God, these kill a lot of birds. Yeah. We got a lot of endangered birds. Yeah. Why do we have a lot of endangered birds? Because we introduce things like cats and rats and all those things. What they often don't tell you, though, is that about half of the bird species went extinct after the Polynesians arrived. So absolutely we're causing problems. Absolutely we have endangered species, but this has been going on for a long time. This is not a new pattern. Go and look at the cloaks, the royal cloaks of the old Hawaiian kings, and you'll find feathers there for birds that no longer exist. So this pattern starts with fishing pressure. Oftentimes because of coastal development, we will get pollution. We next can get physical destruction of the system. It could be by dredging. It could be by putting in, filling in a wetland. It could be a bunch of different ways. We introduce novel species that had not been there, either intentionally or unintentionally, to the system. And then right now we're putting the whipped cream on it with a little bit of climate change, right? Sea level rise, ocean acidification, etc. And all this leads to an altered ecosystem relative to the historic period. And each of these levels are not 1 plus 2 plus 3. They're synergistic, so they interact in ways that are more than additive. And each of these assaults makes them more likely to be for the system to veer wildly away from what it was. It's also important to say that these changes can happen very suddenly. Like this cod story, the change doesn't necessarily have to take centuries or decades even. It could happen in a few years or even shorter than that. Okay, so in summary, historical data can be helpful to frame our current challenges. How do we know we're having a problem? Well, because we've looked. Historical data can, again, be helpful to guide us in terms of restoration, in terms of management. And extant coastal and marine systems can be quite different from how things used to be. We now have a good amount of evidence to suggest that even though there are many ways we can manipulate and impact negatively our coastal ecosystems, overexploitation, removing too many of the individuals that make a population of a particular biological resource, that's often the first step in a pathway towards ecosystem collapse. And overfishing highlighted the importance of overall biological diversity to the health of these systems. When we have these intact systems, they seem to be able to withstand assaults better. But as we start to remove these different components, it gets easier and easier and easier to drive this system to a very different place.